page 11 of our unit packet. So if you guys want to turn to page 11, I'm going to be going over multiplying rational expressions. First things first, if we're multiplying a fraction, let's say I'm multiplying 2 over 3 times 4 over 5. I know that I multiply straight across. So 2 times 4 gives me 8, and 3 times 5 gives me 15. Now, if I had a fraction that was 2 over 3 times 5 over 4, I could choose. I can multiply across first to give me 10 over 12, and then 10 over 12 I'd had to reduce. Or I can actually reduce this fraction first, just because of the multiplication. So if multiplication, I can do it. If it's adding and subtracting, I can't. So if I have this 2, and it's over the 4, I can reduce this to 1 over 2, because 2 over 4 is the same thing as 1 over 2. And then it just makes my multiplication easier. 1 times 5 I know is 5. 3 times 2 is 6. Okay, now let's just talk about rational expressions. So if I have something like this, I'm multiplying. The first thing I should always do is factor. So I'm going to factor each one of these. So x squared minus 36. I noticed that there's only 2 terms, and x squared is a perfect square, and 36 is a perfect square. So I'm thinking this is going to be my formula, a plus b times a minus b. So the square root of x squared I know is x. The square root of 36 I know is 6. So this is going to give me x plus 6 times x minus 6. Now on the bottom, my denominator here, I know this is going to be, I'm going to be able to use my x method. I can use the x method. I don't need the box method because I don't have a number in front of this x squared. It's an invisible 1. So I'm going to take my negative 6, multiply it by that 1. Negative 6 times 1 gives me negative 6. And I take my negative 5, the number in the middle, and I bring it to the bottom. Now here's the puzzle. I want to find a pair that multiplies to negative 6 and adds to negative 5. I know that negative 6 times 1 gives me negative 6, and negative 6 plus 1 gives me negative 5. So that means my factors are x minus 6, x plus 1. So I'm done with this fraction. Now I'm going to go to the second fraction here. I need to factor these two. This is going to be another x method. So 1 times the 1 is going to give me 1. And then 2 comes down in the bottom of my x. I want to find a pair of numbers that multiply to 1 and add to 2. I know 1 times 1 gives me 1. 1 plus 1 gives me 2. So that means my factors here are x plus 1 times x plus 1. And then here, because I don't have an x squared, there's no x squared, so there's nothing to factor here. I just leave this as x minus 1. And I put parentheses. It's a good habit to put parentheses here because I'm going to be crossing things out. I can only cross things out when everything is being multiplied by each other. So what do I have to cross out? I'm going to rewrite this down here. So I'm going to have x plus 6 times x minus 6 over x minus 6 times x plus 1 times x plus 1 over x minus 1. All right, so things that I can cross out. I have an x plus 1 and an x plus 1, so those go away. I have an x minus 6 and an x minus 6, so those go away. X plus 1 and x minus 1, these are different, so I can't cross them out. So I'm left with x plus 6 times x plus 1 all over x minus 1. Now the answer, you can either leave it like this, or if you want, you can choose to actually distribute this out. So I could FOIL this out and I would get x squared plus 1x plus 6x plus 6 all over this x minus 1. And then I would combine like terms here. 1x plus 6x gives me 7x. So x squared plus 7x plus 6 over x minus 1. And this would be, my final answer.